Hey, student, how are you? Welcome to our session on transformations, absolute value. Here we have the parent function, the absolute value of x. Our vertex is 0, 0. Our slope is 1. Up 1 to the right 1, up 1 to the right 1. Or for the left arm, up and left 1. Up 1 to the left 1. We say that this graph opens up. Let's take a look at the transformations of the absolute value function. Starting with our vertical reflection. A vertical reflection is when we have a negative multiplied out to the left of the absolute value symbols. This will reflect the graph over the x-axis, a vertical reflection. We say this graph opens down. Opens down. Next, we have a vertical stretch. When there is a number a multiplied to the outside of the absolute value symbol, and a is greater than 1, we have a vertical stretch. Makes the graph more narrow or skinnier. For example, 5 times the absolute value of x, we see that our slope is now up 5 to the right 1, or up 5 to the left 1, rather than up 1 and right 1. Vertical stretch. Next, we have a vertical compression when a is in between 0 and 1, a fraction. This will make the graph wider. Rather than up 1, right 1, the graph now goes up 1 to the right 5, or up 1 to the left 5. So when you have a fraction in the front here, it will make the graph wider. Let's take a look at a horizontal shift, left and right. When you have a number added or subtracted inside the absolute value symbol, inside the absolute value symbol, this will shift the graph left or right. Horizontal is tricky. Horizontal is the opposite of what you would think. This graph, x, absolute value of x minus 5, shifted our original graph to the right 5. Notice the x minus 5 is inside the absolute value symbols. X minus 5 inside the absolute value symbols shifts to the right. And horizontal shift, when you have x plus h, for example, x plus 5, inside the absolute value symbol, shifts the absolute value graph to the left 5. So horizontal shift inside the absolute value symbol does the opposite of what you would think. X minus h shifts to the right. X plus h shifts to the left. And last but not least, a vertical shift. I like a vertical shift when you have a number added or subtracted outside the absolute value symbol. Outside the absolute value symbol, plus k shifts the graph up, minus k shifts the graph down. For example, taking a look at our parent function, we see the vertex is shifted up 5 when we have plus 5 on the outside of the absolute value symbols, or down 5 when you have minus 5 on the outside of the absolute value symbol. Let's put this all together. We'll take a look at all of our transformations. Starting with negative. Since there's a negative out front here, we know the graph will open down, as you can see here. Then we have A. A is a fraction in between 0 and 1. So that is going to vertically compress or make it wider, since A is a fraction. Then we have our horizontal shift, opposite of what you would think. Since we have x plus 7 on the inside of the absolute value symbols, this will shift the graph to the left 7. As we can see, our vertex has been shifted left 7. And finally, our our vertical shift. Vertical shift plus k. Vertical shift. We've got minus 2 on the outside of our absolute value symbol. So we will shift down 2. And that finishes up transformations of absolute value functions. Thanks so much for joining our session, and I'll see you next time.